4.2 light-years away, a planet slightly larger than Earth circles a red dwarf star. And scientists believe liquid water might flow across its surface right now. We call this world Proxima Centauri b, and it represents just the beginning of humanity's greatest discovery. Planets beyond our solar system where life could actually exist. Tonight we journey to worlds where underground oceans hide beneath ice sheets, where one side burns in eternal daylight while the other freezes in permanent darkness, and where the very air might shimmer with the chemistry of life itself. From planets with diamond rain to worlds where a single day lasts longer than our entire year. Each destination brings us closer to answering the ultimate question. Before we launch into the cosmic unknown, hit that like button and subscribe, because this journey will take us farther than any human has ever traveled. Are we alone in the universe? The answer might be waiting on one of these incredible worlds. Prepare yourselves. We begin. Music, picture a cosmic recipe for life, and you need just 3 ingredients. But getting them right determines whether a world becomes a paradise or a hellscape. The first ingredient seems simple: liquid water. But here's where it gets tricky. Water only stays liquid in what scientists call the Goldilocks zone. That perfect distance from a star where temperatures hover between 32 and 212 degrees F. Too close to the star and your oceans boil away into space like steam from a kettle. Too far away and everything freezes solid, turning your world into a cosmic ice ball. Earth sits right in this sweet spot about 93 million miles from our sun, where water can exist as liquid, ice, and vapor all at the same time. The second ingredient is an atmosphere. But not just any atmosphere will do. You need the right mix of gases to trap heat like a blanket while still allowing light to reach the surface. Think of it like wrapping yourself in a perfect winter coat, thick enough to keep you warm, but not so thick that you've overheat. Venus has an atmosphere, but it's so dense with carbon dioxide that the surface temperature reaches 900 degrees F, hot enough to melt lead. The third ingredient might surprise you: a magnetic field. Without this invisible shield, deadly radiation from space strips away the atmosphere molecule by molecule. Mars once had flowing rivers and maybe even oceans. But when its magnetic field died, the solar wind slowly stole its air away, leaving behind the frozen desert we see today. Here's what makes this recipe so rare. All 3 ingredients must work together perfectly for millions, even billions of years. A planet needs a stable orbit that doesn't swing too close or drift too far from its star. It needs the right size to hold onto its atmosphere, but not so big that it becomes a gas giant like Jupiter. The star itself must be calm enough not to blast the planet with deadly flares, yet active enough to provide steady energy. Scientists have discovered over 5,000 planets orbiting other stars, but fewer than 50 sit in that perfect zone where all 3 ingredients might exist together. Each one represents a potential second Earth, a world where alien skies might shelter alien seas and where the chemistry of life could be writing its own story right now. The challenge becomes finding these needle in a haystack worlds across the vast darkness of space, then figuring out which ones actually have the right conditions brewing beneath their clouds. We've built space telescopes that can detect the faintest dimming of starlight when a planet passes in front of its sun, measuring worlds so distant that their light takes years to reach us. But among all these distant possibilities, one planet stands out as our closest neighbor in the search for life. Just over 4 light-years away, a world orbits the nearest star to our own solar system, and the data suggests something extraordinary might be happening there. In 2016, astronomers detected something that changed everything. A planet just 2 times larger than Earth, circling the closest star to our solar system every 11 days. Proxima Centauri b sits 4.2 light-years away, which means if you could travel at the speed of light, you'd still need over 4 years to reach this world that might harbor the closest alien life to Earth. Here's what makes this discovery so stunning. This planet orbits directly in its star's habitable zone where temperatures could allow liquid water to exist on the surface. But Proxima Centauri isn't like our Sun. It's a red dwarf star, smaller and cooler, glowing with a dim reddish light that would make noon on this world look like twilight on Earth. The planet faces a challenge that would terrify any astronaut. Proxima Centauri b is tidally locked to its star, meaning one side experiences eternal day while the other side freezes in permanent night. Imagine standing on the border between these two extremes where the sun hangs motionless in the sky like a dim red eye, never rising or setting, while behind you stretches an endless frozen wasteland under alien stars. Temperatures on the day side could reach 140 degrees F, while the night side plunges to -40 deg. But here's where it gets interesting. If this world has an atmosphere thick enough to move heat around, the border zone between day and night might maintain temperatures perfect for liquid water. Scientists call this the Terminator line, and it could be where life makes its stand. The real mystery lies beneath the surface. Computer models suggest that if Proxima Centauri b has even a thin atmosphere, wind patterns could create a surprisingly stable climate. Hot air would rise on the day side, flow toward the night side, cool down, and return in a massive circulation pattern that could keep the entire planet at livable temperatures. Recent observations hint at something even more exciting. This world might have a magnetic field strong enough to protect it from its star's violent outbursts. Proxima Centauri occasionally erupts with solar flares 10 times more powerful than anything our sun produces, blasting its planet with deadly radiation. Without protection, these flares would strip away any atmosphere in just a few million years. But if Proxima Centauri b has held on to its air for the 4.88 billion years since the star system formed, that suggests something remarkable is happening there. The planet might have oceans, weather patterns, maybe even seasons, as its slightly elliptical orbit brings it closer and farther from its star. The distance to this world presents both opportunity and frustration. 4.2 light years sounds close in cosmic terms, but it represents 25 trillion miles of empty space. Our fastest spacecraft would take over 70,000 years to reach Proxima Centauri b. Yet, it's so nearby that powerful future telescopes might actually photograph its surface and analyze its atmosphere for signs of life. But this single world is just the beginning of our journey through the cosmos. Deeper in space, an entire system of 7 planets waits. Each one roughly Earth-sized, locked in a gravitational dance around a star so small and cool that all 7 worlds huddle closer to their sun than Mercury does to ours. 39 light-years from Earth, 7 worlds orbit so close to each other that if you stood on one planet's surface, the others would appear larger in your sky than our moon appears to us. The TRAPPIST-1 system packs these 7 Earth-sized planets into a space smaller than the distance between our Sun and Mercury, creating a cosmic dance where each world's gravity tugs on its neighbors in perfect mathematical harmony. This star system operates like nothing we see in our solar system. TRAPPIST-1 itself is what astronomers call an ultra-cold dwarf star, so small and dim that you could fit 12 of them inside our Sun. It burns hydrogen so slowly that it will keep shining for trillions of years, long after our Sun swells into a red giant and dies. The star's faint reddish glow means all 7 planets orbit within what would be the habitable zone around a normal star. Here's where the system gets weird. These planets are locked in what scientists call orbital resonance, meaning their orbits sync up like clockwork. For every 8 times the innermost planet completes an orbit, the next planet orbits 5 times, and the pattern continues outward through the entire system. It's as if some cosmic engineer designed this system to stay stable for billions of years. The 3 planets in the middle of this chain, designated TRAPPIST-1, TRAPPIST-1F, and TRAPPIST-1Gram, sit squarely in the zone where liquid water could exist on their surfaces. But each world faces the same challenge as Proxima Centauri b. They're tidally locked with one side always facing their star while the other side freezes in permanent darkness. Scientists have used the Hubble Space Telescope and the James Webb Space Telescope to peer through these planets' atmospheres as they passed in front of their star. The data reveals something intriguing. At least 3 of these worlds might have substantial atmospheres, and one shows possible signs of water vapor floating in its air. The real mystery centers on TRAPPIST-1e, the 4th planet from the star. This world receives almost exactly the same amount of energy from its sun as Earth receives from ours, making it potentially the most Earth-like planet we've discovered. Computer models suggest it could have a thick atmosphere that distributes heat around the planet, creating moderate temperatures even on the permanently dark side. If you could visit TRAPPIST-1e, the experience would be unlike anything on Earth. The star would appear about 3 times larger in the sky than our sun, glowing with a deep red light that would make the landscape look like it's lit by firelight. The other 6 planets would hang in the sky like jewels, some showing crescents, others appearing as full disks, their positions changing as they orbit in their cosmic clockwork. The gravitational interactions between these 7 worlds create another possibility that excites scientists: tidal heating. As each planet's orbit gets stretched and squeezed by its neighbor's gravity, the resulting friction could warm the interiors enough to keep underground oceans liquid, even on worlds that seem too cold on the surface. Recent atmospheric analysis has revealed that these planets contain different amounts of water, suggesting each world tells its own story of formation and evolution. Some might be water worlds with deep oceans, while others could be rocky desert planets or ice-covered moons with hidden seas. But among all the worlds we've discovered, one planet stands out as Earth's closest twin, orbiting a star so similar to our Sun that scientists nicknamed it Earth's older cousin, 1,400 light-years away. A planet takes 385 days to complete one orbit around a star, almost identical to our Sun, creating seasons and a year length so close to Earth that you could use the same calendar. Kepler 452 tube orbits within its star's habitable zone at just the right distance for liquid water. And this world has been doing so for 6 billion years, 1.5 billion years longer than Earth has existed. Here's what makes this planet extraordinary. Its star Kepler 452 burns with almost the same temperature and brightness as our Sun, providing steady, stable energy that could support complex life for billions of years. The planet itself measures about 1.6 times Earth's diameter, making it what scientists call a super-Earth, large enough to have a thicker atmosphere that could trap heat and protect the surface from radiation. The gravity on Kepler 452 would feel about twice as strong as Earth's gravity, meaning if you weigh 150 pounds here, you'd weigh around 300 pounds there. Your muscles would adapt over time, but jumping or climbing would require much more effort. The stronger gravity also means this world could hold onto a thicker atmosphere for longer periods, potentially creating more stable weather patterns than Earth experiences. This planet's year lasts just 20 days longer than an Earth year, and its orbit sits in nearly the same position relative to its star as Earth sits relative to our Sun. If Kepler 452 has seasons, they would follow a familiar pattern: spring, summer, fall, and winter, lasting roughly the same length as Earth's seasons. Trees, if they exist there, might show growth rings similar to Earth trees. The age of this system raises fascinating questions about what might have evolved there. Earth's most complex life forms have only existed for a few 100 million years, but Kepler 452 has had 6 billion years to develop life. If biology took hold on this world early in its history, we might be looking at a planet where evolution has had 50% more time to create incredible diversity and complexity. Computer models suggest that if Kepler 452 started with the same amount of water as Earth, it might have developed into an ocean world with small continents scattered across its surface. The stronger gravity would create more dramatic tidal effects, potentially leading to larger tidal pools where early life could have gained a foothold before spreading to the oceans. The star Kepler 452 is about 1.5 billion years older than our Sun and burns slightly brighter. meaning this planet receives about 10% more energy than Earth receives. This extra energy could drive more active weather patterns, stronger storms, more evaporation, and more dramatic cloud formations that might be visible from space as swirling white patterns against blue oceans. Recent analysis of this system suggests something even more intriguing. As Kepler 452 ages, it gradually grows brighter and hotter, just like our Sun will do in the future. Kepler 452 might be showing us what Earth will look like in about 1 billion years when our Sun's increasing brightness begins to boil away our oceans and make our planet uninhabitable. If this world has developed life over its 6 billion year history, that life now faces the same challenge Earth will face in the future, adapting to a gradually warming planet as its star grows more luminous. The solutions life finds on Kepler 452 bits might teach us how future Earth organisms could survive similar changes. But while Kepler 452 offers a glimpse into Earth's possible future, another recently discovered world provides hope for finding life much closer to home. Just 137 light-years away, a planet 1.5 times Earth's size completes an orbit around its star every 19 days, positioned precisely in the zone where liquid water could exist on its surface. 2OI 715 represents one of the most recent additions to our catalog of potentially habitable worlds. Discovered in late 2023 using NASA's Transiting Exoplanet Survey satellite, this world orbits a red dwarf star called TI 715. Much smaller and cooler than our Sun, which means the planet must huddle close to receive enough warmth for liquid water.